Thank you. Next coming is Mr. Ronald Deepak, Business Development Manager from Emerson. The title will be Empowering Workforce Through Experts Insight on Improvement Process, Plant Reliability, using Connected Services.
Excuse me. Could you please take some questions on
Not, yes, it will be taken, but immediately after the session is over.
after the
Yeah.
second session?
Yeah, no, this session only. We will be finishing session after our guest finishes. Okay. If there is a question answer, space is available.
Presentation questions?
No, but please wait. We have to finish up. We are running out of the time also. We will give you sufficient time. Huh? Huh. Yes, it will need improvement. I will request the guest. Okay, thank you, sir, for this session.
A very good morning to one and all present here. I am Ronald Deepak from Emerson, and firstly I would like to thank the organizers for giving us this good opportunity to come and present in this elite forum. So my topic for today is empowering workforce through the data from the smart devices in the field. So my area of work with Emerson is on control valves, and I'll share a bit of what we have done on control valves in terms of the IIoT concept that we have been discussing, and how it can help the workforce in the process industry in ultimately improving reliability, safety, and performance of the process plants. So with that, let me talk about today's industry and how it operates. What are the challenges? The challenges may be specific to certain equipments like control valves, and some of the challenges may be common across equipments. But today's process industry globally is operating with a lot of higher expectations and with less resources. Like Madam was pointing out, a lot of constraints in terms of shutdowns, which really affect the output or the production in the plant. More reliable, better performance is expected with less spending. And if you talk about maintenance shutdowns, the time between maintenance shutdowns is getting on extended. That is what we generally observe. So all these trends actually put a lot of stress on the equipments operating in the process or in the plant. And a survey done globally says that production plants lose somewhere like $20 billion annually just due to unplanned shutdowns. $20 billion is roughly about 5% of their annual production. So imagine losing 5% of the production just due to unplanned shutdowns. And the closely associated fact is that many of the safety incidents which happen in the plant occur during a reactive maintenance. Normally, when there is a failure of any equipment in a process plant, the maintenance people work on a war footing. They are virtually in a panic mode, and their intention is to get the plant up and running, right? So many of the safety incidents that we see happen during reactive maintenance because the people are really in a panic mode, and the priority is to bring the production up. So our objective at Emerson is to improve the reliability of the equipments of the field devices working in the plant. And today I'm going to show you a little bit of how we can do this through the use of technology, more specifically with the industrial Internet of Things catching up, and with more experience that we build up globally in various plants. We are able to take those best practices and how we can implement them across the industry in India, and how it can empower your workforce with more data that can help them to make more informed decisions. So I'm going to talk about a diagnostic service which is focused on producing predictive analysis of control valves, which is basically how you can monitor the health of control valves, identify potential failures before they happen, and ultimately it will positively impact the operational metrics of the plant in terms of reliability, performance, emissions, and overall safety of the plant. If you look at a traditional way of maintaining assets, I can say traditionally it is all done on a reactive basis. A failure happens, and then people start to work on the failure and then try to bring the equipment back on. So if you look at a control valve, for example, traditionally once a failure happens, only then all this maintenance or failure and repair it happens. Now our intention here is to do or bring the maintenance before the failure, so that we avoid unplanned downtime in the plant, and we are doing continuous research in methods to detect failure conditions well before it happens. So right now we are in an online diagnostic way of predicting failures, and in future we also expect that we will go to things like process variables, acoustics, vibration and whatnot, so that the failures can actually be predicted, and we can have more insights on the health of control valves. And what we have seen is control valves are very often a source of failure, and ultimately unplanned shutdowns happen due to control valves in many occasions, whether it may be an oil and gas plant or a refinery or a fertilizer plant. So these trends are very common. So what is it that we are trying to do? So Madam Vartika was talking about connecting devices, or she put it Facebook of machines, right? So rather than having individual devices or individual valves, we now are talking about connecting them with connecting them one with each other, and also having an overall perspective on how they operate, so that we have data to find out when a failure can happen, right? So this is our connected services model. So you have the site here where we have various field equipments. I have shown the control valves here. Then we get the data from those devices back to our monitoring stations. So this is where our experts retrieve and also analyze the data being obtained from the field, and based on the data they give some recommendations to the site on possible maintenance or possible precautions they can take to avoid failures. So the communication from the site to our monitoring experts can happen automatically through data transfers. We can have schedulers which automatically populate the data on a regular basis, or we can have somebody manually if there are some data security concerns. For example, instead of doing automatically, we have persons dedicated to send this data from the field to the experts who will monitor and analyze the data. So this is basically the communication path what we normally implement at the site. Okay, so what is the requirements in terms of hardware and software to have this done? The critical requirements will be the digital valve controllers on the valves, the diagnostic software in the host system or the engineering station, and the recommendation is to basically have the PD we call it as a performance diagnostic, which basically gives a real-time online diagnostic alerts and also diagnostics to the host system or the engineering station, and also the on-site personnel who are familiar with how to operate this. So really, when we offer this connected services as an offering to the site, we not only install the equipment and the software, but also train the workforce on how to keep the diagnostics running, and how to collect the data and how to analyze, so that over a period of time their dependence on the experts sitting off-site will come down, and over the period of years the maintenance people in the site will have more and more skills and also resources to do this diagnostics by themselves. So what are we trying to achieve here? So we are trying to improve reliability. That is, as part of the offering, we are giving access to skilled experts who can actually predict potential failure conditions, and ultimately give you better insights into the health of the valves. Performance wise, the reliability gets improved, which means that we reduce the unplanned shutdowns. The better diagnosis will mean that the loops are operating close to set points, whether it is a flow loop or a level or a pressure loop, they are operating close to the set point. So we reduce the loop variability, and in certain cases it can mean energy savings. Like for example, a valve is leaking continuously. So by addressing it through diagnostics, we are able to save the leakage, for example steam in a power plant. So those kind of savings can be realized by using the diagnostics. On the maintenance standpoint, normally we see that the planning for the shutdown is a very tedious job, both in terms of the resources as well as managing the inventory or the spare parts which are required to overhaul the equipment. The diagnostics, what we do on the valves, will actually give us a lot of data, a lot of idea about which valves you need to focus during the next shutdown. And this will mean that you're actually going based on the data rather than, without having any background on the valves to be overhauled during shutdown. You now take a data-driven maintenance scheduled for the upcoming outages and the shutdowns which you are planning. So really overall, the connected services will help you throughout the life cycle of the valve in terms of reliability, performance, and maintenance planning. So what are the impact metrics? So we do all these diagnostics and we do the analysis of the data from the field, but how do we measure it and how do we ensure that this service is actually successful? So we have impact metrics in terms of the unplanned downtime, in terms of predictive maintenance tasks. So normally the maintenance happens on a reactive basis, but by these connected services we intend to have a data-driven predictive maintenance happening. And overall we want to reduce the maintenance spent on the valve assets, that is increase the predictive work orders and reduce the reactive work orders. And the fourth one is improve the outage planning. The shutdown planning can really be improved by the use of the diagnostics so that the control valve assets can be maintained in a much better way. So the next question would be, what equipments to monitor, what valves should we monitor? In a refinery you may have hundreds of valves, right? So which valves should we monitor? Because you will have less time and resources to basically monitor each and every valve within a refinery. So our recommendation is to target the most critical valves, valves which are throttling, valves which have been prone to failure, valves which are in very inaccessible areas like remote locations. So, and normally the plant has a history of certain valves which normally give the problems. So those valves should be targeted and those should be monitored. And how we do this service implementation is, first we do a installation and visual inspection, and we collect all the data related to the existing valves. We configure the diagnostic software in the host system or the engineering station, and then we ultimately schedule the data to be transferred on a periodic basis. So this whole service works in 4 different steps. First is, like I said, we acquire the data from the field through the diagnostic software, and the data comes from the field positioners. We then transfer that data on a weekly or a monthly basis as it is deemed fit for that particular application, and we analyze the data. That is our experts sitting in various locations. It may be across India or across the globe. The data is analyzed, a time series is plotted, and I'll show you a sample report, how this analysis is done. And finally, using the data and the reports, we send some meaningful recommendations for the plant to act on. So let me show you an example of how the report looks like. So if you look at this chart on the top left, you see a bar graph showing the total number of valves installed in the site. So here you can see 25 valves are being monitored, and the green ones, the green bars show the valves which are operating fine. The yellow ones have a potential problem, and the red ones have a kind of a failure condition predicted, so that immediate attention is required. On the right side you see a time series of the various valves and how they have been performing over a period of time. You have a time stamp on the top. you have a timestamp here, the month and year is shown, and in that particular month, whether the valve was operating in a green or a yellow or a red, that graphically we show. So looking at this graph, you can see those valves which have yellows and reds, those are the trouble making valves, right? And on the bottom left, you also see a graph which shows the cycle counts. Like for our vehicles, we have the odometer which shows how long the vehicle has traveled. So for a valve, we have something called a cycle count, how many cycles the valve has operated. So overall for the plant, you can see that some valves are operating very frequently, right? So this data can be used in two different ways. One is whether your set point is changing exactly in those loops, which is warranting the valve to operate so frequently. Second, from the maintenance standpoint, you can actually look at these valves for the next upcoming shutdowns because they've been throttling very frequently. So this sample report is sent on a monthly basis or a bi-weekly basis as required. And for those valves which we have predicted some failure or failure actually has happened, we give a detailed report. For example, this particular valve is shown in red and this one is shown in yellow. So this particular valve had a high drive signal on the positioner, and some recommendations are given to change out certain components. So this failure may have happened very recently, and immediately the report actually identifies the problem and what is the recommendation to sort out the problem. So this kind of meaningful reports will really help the maintenance people in the plant to take very informed decisions and also to schedule maintenance on these valves in the upcoming shutdown that is planned. Just a case study from a major chemical company in the US in the Texas Gulf area. So this particular plant had a critical valve which had a major supply pressure problem, and this supply pressure problem was identified by the positioner diagnostics, and an alert was sent to the plant operators, and it was attended to immediately. And the plant said that if the valve had closed, the entire plant would have shut down because it's a critical valve, and the plant would have been down for at least a day. So this was a major saving that the plant realized by predicting a failure in the valve. And this is just one example of how this connected services can help the plant to improve reliability and safety. So what are the benefits for the plant? So you maximize your investment in the technology. Many plants do have the infrastructure, but they don't have a proper system or a way in which they will use the data from the devices and use it meaningfully to impact the operational metrics. So this service will help in maximizing the technology investment, and you get access to the experts who can actually tell you what is wrong with the equipment and how to sort it out. You can improve safety through the connected services by avoiding failures. You can better plan for the shutdowns. So you have all the data from the field devices, which will actually take you to a data-driven maintenance rather than a reactive maintenance. And overall, it helps you have operational certainty. By operational certainty, we mean you ensure safety, you have more reliability, you minimize the emissions, and also you optimize the production. So just to summarize, this connected services, they are scalable. You don't need to invest a lot of money and spend a lot of time looking at all the equipments or all the valves in your plant. It is scalable, meaning that you can start small, start in a very small area, implement this, focus on critical control valves, and based on the success of this service, you can extend it across a plant. And it helps you realize your investment in technology. We see that today in the market, everybody is buying smart positioners along with the valves, but the realization of the data available from smart positioners is not there. So this will help you realize that investment. It can help you identify critical valve failures very early, leaving you sufficient time to repair. and avoid unplanned shutdowns in many of the cases. The service provides an expert to you to sort out control valve issues on a regular basis, and ultimately it positively impacts all your operational metrics. So that's all I have from my side, and thank you very much for your attention.